Okay, so today we're gonna go ahead and deal with comparison operators. So here they are. I mean, we did mention them and we did do them before, but so you have a lesser than, greater than, I don't know, lesser than or equal than. Let's go ahead and write pretty much all of them. Have greater than or equal to, not equal, and yeah, that should be it. Okay, with these operators, we can compare only pointers that point to the same type. If the types of variables that pointers point to are different, oh, sorry, I've just yawned. Wow, okay. It's pretty late and I'm pretty tired, but it doesn't matter. I shall push on. Anyway, if the types of variables that the pointers point to are different, compiler will basically report an error when comparing them, even if the types are basically comparable. For example, I don't know, like a floating point and an integer, or a double and an integer. Double can be greater than an integer, so they are comparable, but still, the compiler will report an error. If we compare pointers by equality of P and Q, and if P and Q basically point to the objects of the same type, then you would write something like this in order to compare them. So it sounds more complicated than it actually is. Just P equals Q. So there we go. So we're just comparing whether they are equal or not. So pointers P and Q are equal if they point to the same object. Other comparison operators are different only if the pointers P and Q basically point to the objects of the same array. Anyway, so these two pointers are equal only and only if they are pointing to the same object. If you were to write something like this, I don't know, P is less than Q. I don't have another pointer here in the code, so I'm just imagining and pretending that Q is another pointer other than P. But it doesn't matter. We're gonna go through the actual code and we'll see what this actually looks like. I just want to go over a little bit of theory with you before I get into a small demo down below. Okay, so if I write P is lesser than Q, pointer P is less than Q if the array element to which P points has a lower index of the array element to which Q points. So, for example, this element would have a lower index as opposed to this element, because this index is 6 and this index is 0, 1, 2. Okay, so this index is 2 and this index is 6. So it's not your standard comparison that we're dealing with here. Basically, so that the pointers that do not point to the elements of the same array, they cannot be compared in terms of size. Keep in mind that the statement that we have used a moment ago, like this equals, differs from this expression. So it completely differs from this expression. And you have asterisk P and asterisk Q. The previous one, the P equals Q, compares locations that those two pointers contain, and they can be different even though their content is pretty much the same. But the one that I'm showing to you now, the asterisk P equals asterisk Q, compares the content to which these two pointers actually point to. And they may be the same if the locations are different. So I don't know, you could have a number 20 at this location, and here you could have a number 21, which would mean that they're not actually equal. So there's a little bit of trickery going on with pointers and comparison operators that you need to be aware of, and you need to be well, you just need to be aware of it so that you don't make any stupid mistakes in a logical sense, which logical errors are probably the most difficult to find because the compiler doesn't warn you and you gotta like dig. Some of them, as I mentioned a moment ago, you will be warned about, but some you won't. Anyway, we're gonna have ourselves another pointer here. It's going to be double Q. I'm just going to put it there, and this is going to point to the last element, I guess. I'm just going to go ahead and copy this. Well, last element plus 1, I guess. Just going to leave it like that. And then we're going to go ahead and have, like, well, we're not... Let's go ahead and leave that, delete this, and we're going to use the while loop. So while. Okay, just going to use the while loop here. We're going to say while P is less than Q. Okay, so while P is less than Q, this logic will execute. And you can also do this. If you didn't know, you can write this in the same line. Like this. And it will work in exactly the same way. Just going to save this and run it. And there you go. It actually does indeed go and loop through the entire array because basically P begins at the first element and this ends at the next to last element. One element past the last element. So this is just going to iterate over and over and over and over and over until all the elements are iterated over and until they are all printed out. If we wanted to print the array in reverse order, it's really not that difficult at all. You can change this from 07 to 06. Oops. And then it's going to be while P is... Just going to type in greater or equal to Q. You can change that because we have reduced this count by 1. So it's greater or equal to. And we shall type in Q here minus minus. Okay, so let's save this. Build and run. Nothing is printed out. Okay, let's have a look and see where the mistake lies. So these two should be perfectly fine. So it's 0 and 6, P and Q. 0 and 6, P and Q. Okay. All right, of course. Should have reversed these two as well. Q, P. While Q is greater or equal to P. So while Q is greater or equal to P, Q begins with 6 and P begins with a 0th element. And Q is being reduced continuously. So as long as it's greater or equal to, keep doing it. When it becomes smaller, stop doing it, which inevitably it will. Okay, let's save this and build and run. And there you go. We get a reverse printout here. Okay, so I'm going to go ahead and bid you farewell, and we shall see each other in the follow-up tutorial.